one of the most confusing concepts in C programming, which is C pointers. So pointers are really important in C because they are used in so many applications, but they are easy to understand. Just that if you like a good introduction to it, sometimes you get confused about it. Yes, so I'll be talking about pointers. Yes, so today I'll be talking about pointers. Now, what exactly is a pointer? So a pointer is another variable that stores. So a pointer is a variable that stores another variable, right? Yes. So it's just like another variable, or let's say which also has a type, right? So you have to define what type it is, right? So it's also a memory space that stores the address of another memory space. Do you understand? So in C programming we have different types of data types. And so we declare variables specifying data type, which type of data type it is. And in memory, this is what happens. So for instance, if if you have a variable like an integer in memory, and let's assume this is my memory block. Then in the memory we can have, so in computers our memory is like a contiguous block of bytes which are given addresses starting from 0 to the last available space, right? So in this case, we have, like, let's assume we are at a certain location in memory. Let's say at A1, and then let's say we are at A2, and then A3, A4, A5, A6, then A7. These these are addresses, right? So this is the address of the first block. Right, right. Is the address of the first block of bytes. And in here we can store data. So when we declare a variable, let's say in C we declare a variable like um var, let me say int var equals certain, let's say 70, initialize it 70. Then in memory we can have, so in some platforms our integer variable is, let's say let me say uh, so our integer variable is four bytes. So meaning that this 74 will be stored on this. Now 74 in hexadecimal is, so let's say is what was it here? 4A, 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 4A. Right, so we can store our 4A in memory. Now let's assume we have um a little endian, right? A little endian architecture. Then in memory we have 4 bytes. So let's say we have A1 up to 4 as our integer. So that being the case, That being the case, we can have a variable stored like this. So we can have let's say 0, 0, 0, 0, 0. And then you can have a 4, 8, right? So we have 0, 0, 0, 0, 0. So the whole of this memory is reserved for a byte, right? Which is four, supposed to be 4 bytes, right? So you have, okay, that's like 4. Yeah. So the whole of this is 4 bytes, right? So that's what we have as that's what we have for pointers, right? No, sorry. So that's how a variable is stored in memory, right? Now, if you want this int var, we can access the address of int var using the ampersand operator. So let's say, for instance, we use another line like this line. So let's say we use another line like this. Let's say printf. Let's say printf, and then we have this. So for to print an address, we use the string formatter, right? Then we have this. There we go. And then the address of this can be accessed. You can print the address of any variable by using the ampersand. You see. So let's say this my ampersand. That's really like choosing. It isn't really good looking one, but then and then we have our var. So we have something like this. So this will print our address. Now, the address of this particular variable in this case is the address of the first byte, which is A4. Do you understand? So the address of the first byte is A4. Oh, the address of the first byte is A1 rather. So let me see if I can get this. Okay. Yeah. So the address of the first byte, the address of this is O A1. So when we print this should give us A1. Okay. All right. Now, we want to store this address rather than printing it. We don't want to print this address, right? So this is what is going to be printed in our console. But that's not what we are interested in. We are interested in storing this address so that we can use it when we want to use it in our program. All right. So let me clean all this. All right. So now for this particular variable that we have to store a pointer to it, or we want to store its address, we want to store the address of this variable in memory. How do we do that? That's where pointers come in. So in declaration of pointers, generally they follow this structure. Let me say, yeah, this structure. So we can have in declaring the pointer, you mostly use the asterisk, should I say that, this pointer to identify what a pointer is, or to declare a pointer. So, and then we use the same thing to dereference pointers. Dereferencing pointers is like telling the compiler to go to the address and then bring you all the data in that address. Do you understand? Yes. So let's see how it is done. So for instance, we have the data type mostly here, data type, and then we have the name of address. So we can have, and then we have asterisk in the name of the address. So name of pointer, let me give it ptr equal to the address of that variable. So you can use trampers and forgive me my writing is like terrible. So var, then so we have data type pointer pointing to our variable. So it will point to the address of our variable. In this case, our address is the address is this. So we don't store the address of the address for let's say A1 to A4, but we know that an integer, right? We know that an integer, an integer on this platform, every platform knows the size of its integer. So when we go to the first address, we read the next 4 bytes starting from that address. Do you understand? So in this case, you have data type pointer, then var storing the address, reading from A1 to A4. You get it? Yeah, so we store A1, we only store A1 as var. So the value of var is A1. All right. And then since it's an integer, you read 4 bytes, continuous 4 bytes. So you have other data types like long int, and then we have short integer. Then we also have character. Right. So in this case, this is the general way that we define pointers. Right. So we can also define pointers in other forms. But not in other forms. Always like, yes, in other forms, functions, it's similar but then quite different. We talk about functions, pointers to functions as we move on. So now that I have my, so in our actual programs, for instance, for this particular variable, you have int, then we have pointer pointing to the address of this integer. So then we have something like that. So in this example, that's what we are going to have as a pointer. So now our pointer, as I said, is another variable. So this time, if we print ptr to our console, it's going to return OS1. So this is what we are going to print on our console, this address. So now pointer is storing this address. So in my program, I can get access to this variable using the pointer. I hope I'm clear enough. So in a C program, you have different memory. For a program to run, the operating system allocate memory for the process. And two particular memories that I want to talk about. Later, we'll talk about the other sections of memory that is allocated to the process. So two important memory allocations or locations for a process is the stack and also the heap. So whenever a program. Whenever you want to run a program has a stack. The program has a stack and it also has a heap. So what is what is the stack and the stack is and a heap, right? And heap and heap, right? So we can have a stack and a heap, right? So why do I want to talk about stack and heap? Yes. So whenever you have a function, 'cause mostly all our C programs start with a main function, right? So the stack looks like something like this. Yes. And then on a stack we can have different function calls. This is what happens. So you can call, let's say, main. Always main is our first function in stack or in the C program. So mostly first function that we call is main. So whenever you call a function, the operating system creates a stack frame for the function. So what we have right here is the main stack frame, right? So this is some block of memory, right? It's not just one byte of memory, but a block of memory from, let's say, location O X to, let's say, O Y, right? So the size of the block of memory is O Y minus O X. We don't know what X and Y is, so we can't really say the size of the stack frame, right? But it depends depending on the platform, we get the size of frame, that frame. So what happens is that whichever local variables you declare inside main. So whenever you have a C program, you have int main, and then let's say like then you have something like um, you declare variables here. Let's say variables, and then let's say we return a zero, right? You have something like this. Now when you call this, the variables that you declare in here, the variables, they are stored on your stack. They are in here. Yes, they are stored in here. You get access to them, whichever variable, arrays, integers, floats, they are all stored on stack, right? So when a function returns, when if and we call these variables local variables because they are local to the function. They are only available to the main function. They are not available outside the main function. They are local to the main function. Likewise, if you have another function, let's say you have another function called, let's say, star, then we have, let's say, void, then and then you declare some variables in here. Likewise, a stack frame we created for this particular, not stack frame is only created when, let's say, we call this function. So we are told that for C programs, the first function that is called is main. That's why I have my stack frame for main in here, right? But then in for this one, we've only declared or we've only defined our start function, but we haven't called it. So a stack frame wouldn't be created until, let's say, inside main we call a stack frame in there, right? Call a stack frame in there. So let me say we have um inside the main we call a stack frame, right? So let's say we have start here, right? If you call start like this, then if we have So in here we can have, after calling start, we can have start frame created for start, right? And this will be start. Now, if start also had like some local variables, the variables that we have here, some of them are passed to the function. So when you pass a variable to the function, a copy of it is also stored to stack, right, as local variable. And then when you declare variables inside the function also, they are also stored on stack as local variables, right? So that's about stack. And then when the function returns, the stack is popped, right? Let's say we return from start, right? If that happens, then the stack is popped, right? Now why am I talking about this? Let me talk about let me talk about let's talk about heap also. So on the heap provides us with the heap. Every process has a heap memory. So in the heap, all dynamically allocated variables are stored on heap, right? So the heap is for dynamically allocated variables. So your program, you can dynamically allocate variable using malloc, right? Malloc. And then for each malloc that you call from memory allocation, you need to free the memory, right? So whenever you use malloc, which is telling the operating system to allocate a certain block of memory, right? To allocate a certain block of memory for it to store a variable. Whenever you call this, that memory allocation is allocated on heap, right? On heap. So that's about it. Now, I'm talking about this because we are going to talk about how pointers help us to find these variables, especially on the heap. So 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 if we have so my assumption is that you already know about um structures, and you also know about basic data structures. Sorry, data types like integer, floats, and others arrays. So in your program, when you are writing your program, and then you write, let's say, int main void. Then you have this, then you have int array, then you have, let's say, 20. Pause the video and tell me where this variable will be allocated, right? So in along your program, you have your return, and also maybe you maybe, let me make it this way so that it's to be. Let me just make it let me see. Let's say we have this. um, So let me make it, let's say, 3. We can have 1, 2, 2, 3. So let's say in your program you have something like this. Where are we going to store this memory array? Will it be stored on heap, or it will be stored on the stack? So the answer is it will be stored on the stack. It will be stored on the main stack, right? It will be stored on this. The reason is because this is a local variable to main, so it will be stored here. In what cases do you have a stored, do you have a variable stored on a heap? So I said that whenever you call malloc, it is stored in here. So let's say in your program, you have something like this. In your program, you have something. So let's say in your program, you have, let me say, so, so this is how the operating system manages processes, right? By creating memory allocations for the processes, right? So it creates memory allocation for the process so that the process can run successfully. Yeah. So in the second instance, let's say we have int array, right? So now if you're using memory allocation, this is where you use pointers because malloc returns the address of the block of memory that it's allocated. So let's make this one an integer. Let's typecast. So this typecasting, what we have over here is typecasting. So typecast and then allocate memory of size integer. So normally this is array. So let's say we have something like this. So this variable is going to be stored on stack, right? So I have malloc, you can allocate any size of memory, any block of size. So this size, malloc take the number of bytes you want to allocate. Size of int returns the size of integer depending on your platform, right? So it is allocating number of bytes that's necessary or needed to store an integer. And then it returns the address of the memory. But then the address of the memory, the compiler doesn't know whether it is an integer or it is float. It only knows it's just an address of memory. So it returns, let's say, you see, I said that you have series of bytes, right? So for an integer on some platforms, it is 4 bytes. For 4 bytes, we have integer one, two, three. Let's say four, right? Sorry, byte one, two, three, four. We should have an integer stored in here. You understand? So if you have this stored in memory, we are only going to return the address of this. Let's say this is O A1, O, O, A2, and O, A3, A4. So we are only returning the address of this. When you do this int malloc size int, what happens is that you only return the address. So it will return this address O A1, right? It is allocating this memory. I shouldn't have added any data to this, so let me just delete the data because we are only allocating three block of memory, right? So although we probably have some garbage data in there, because since the memory locations are just transistors of some state, so it could be 00 if all the transistors in that particular memory block location are not activated. So we have some garbage data in here, and then the malloc allocate this memory, this four block of memory. It allocates, but it only returns this address. So unless we typecast it as integer, unless we do this, the compiler wouldn't know that we are accessing 4 bytes, right? We are accessing, the compiler wouldn't know that. Like for instance, it wouldn't know that this address the pointer, if you don't typecast it. Anyway, in on most platform, it automatically typecast it to integer if you have this type of variable. Now, assuming that I instead of doing um allocating, let's say 4 bytes, right? Instead of allocating 4 bytes, I allocate, let's say, 5 bytes, right? 5 bytes. If I typecast this, it will only be focused on 4 bytes integer, right? And then the last byte wouldn't really be accessed. So you typecast it to tell it it's an integer variable so that the compiler will know that it is A2, A1 to A4. That's why we typecast malloc. It is advised good practice. So normally you do this. The malloc returns a type called void this. So the default typecasting is void strings. So unless you typecast it, you need to know that it is pointing to an integer. Right. So that's all about it. I hope I'm clear enough. This like my first time using this, so forgive me if I've been stopping, breaking. So that's about a heap, and as I said, this is stored on heap, right? So that's all about the heap, and then the stack, how they play, the pointers play a role in it. Now, I've only been talking about pointers to integer. And you can have pointers to have um can have pointers to any other variable. Also, you can have pointers to floats. And then so we have two type of arrays in C. Since I've already talked about malloc and also talked about pointers, let's talk about this. So in C we have arrays and we also have dynamic arrays. Right? We have static arrays and we have dynamic arrays. So for static arrays, they are stored on stack, right? They are stored on stack, right? And then for dynamic array, they are stored on heap, right? So you could see how that would have been like. So we normally declare static array using this, right? Saying this is a static array. And what we did earlier on, you can have um, this integer, right? Pointer, right? And then it's pointing to malloc, some block of memory. So size int, size of, sorry, it's supposed to be size of. So let's see if I can clean this. So size of, so it's supposed to be size of. So size of, size of int times the size of the array. And so these two, this, let me make it dynamic array. So we have the array, right? So these two, this is stored on stack and then this will be stored on heap. So this is also an array, right? Array of integers of size n. Let me make this one also n. And this is an array of integers of stack of size n. But then the difference is that this is stored on stack and this is stored on. And so mind you, whenever you do this variable array only stores the first address of the array. So we can have an array like this, right? And each of the variables starts from some address to some address, right? And then we can index it from 0 to n. So the address of the first one is stored in this array, right? Likewise, the address of the first element. I mean, I showed you how malloc works. It returns the pointer to the first memory in the block of memory that you allocated, right? So that address is stored in dynamic array. So these are two types of arrays that we use in C. We'll talk about them more later. But today we are still talking about pointers, and I've showed you their uses and the application. So let's talk about other types of pointers other than the pointer to integer. So you can have a pointer to float, like you can have float, then pointer to float, go to some float. And then we can also have a pointer to character. So you can have car, then you have pointer to the character, some character. See, so always remember you take the address of some variable and then store it in this pointer. So address of some variable, right? And then you can also have a pointer to pointer. So let's say you want to store the pointer to this pointer. So it will store the address of this pointer. So that's how you have to, yes, because this is a type car pointer and then pointer to that. So it's like something like that. So these are pointer to pointer, right? Pointer to pointer. Also, we can have pointer to function. So you can have pointer to function, and this is how we declare our pointer to function. Have a pointer to have a pointer to function, right? So we can also have this, let's say a function pointer to function, right? So func pointer. Then we have this the type of data. Let's say we pass the float into this, and then so this is the declaration of pointer function, and then the function we are trying to point to has this how do you even call it? Yes, prototype, if I'm not wrong. So the function has this prototype. So if you have a certain function, let's say add, yes, let's say add, which has this prototype fleet, right? If you have the function like this, then we can store this function pointer with that, right? Can store this function pointer with that using the address here, the address of add. So this pointer will point to this function. It will store the address of this function. So when you declare functions, they are also stored on memory as text. So we have another block of memory called text, right? So this block of memory is where your code is stored, your instructions are stored. So it allocates some block of memory and then stores your instructions inside this function on on this section of memory. So now your func pointer points to this. So whenever, so you can call this function using func pointer like this. So you can have func pointer, and then add, let's say some floats here, right? Some pass some floats, let's say 4.21, right? I need to add it to, let's say this add function as the float to ask the flow to I and then print it on the screen. So that's what this, when you do this, that's what will happen because you are pointing it to that function. So that's how function pointers works. As for the car pointer and the float pointer, they work similar to the integer pointer. Okay, so that's all for now. I'll do later video to clarify things, but then for now, this is all about pointers I want to talk about. Leave um so like this video and leave comments and subscribe to my channel for more for similar videos like this in future. So I'll be talking more about C programming and also data structures using Python in future videos. Yes. And I'm also thinking of maybe um, adding more tech content like interview some of my colleagues who are also in tech for them to give you guidance and share their experiences. So that's all for today. See you next time.